Okay. When the x is the independent variable and the y is the dependent variable. Slope is the rise, how much you go up over, say it again, Tessa. Yeah, rise over run. And then that little m equals, that's going to be an equation. And it's going to be written as a fraction. M equals y sub 2. So that little 2 is written lower than the y. Y sub 2 minus y sub 1. So it's like the reverse of an exponent. It's down low. Over x sub 2 minus x sub 1. So we're going to use all of these concepts interchangeably because they all mean the same thing. Rate of change, slope, and m equals, they're all the same thing, okay? So we're going to sometimes use the change in y over the change in x. Sometimes we'll count the rise over the run on a graph. And sometimes we're just going to use 2 points and calculate y2 minus y1 over x2 minus x1. They all mean the same thing. So let's use this table to find the rate of change. So remember, for the rate of change, and I abbreviate that as ROC, we're looking for the change in y over the change in x. Time is always my x-axis, and it says it right here. X, distance traveled is my y. So we have to figure out the change in y first. So to go from 0 to 76, what did I do? And the change is going to be a plus or a minus. Plus 76. Thank you. To go from 76 to 152, what did I do? Plus 76. To go from 152 to 228, plus 76. Now let's go to the x side. To go from 0 to 2, what did I do? To go from 2 to 4, what did I do? 4 to 6. So my change in y, which is 76, over my change in x, which is 2, equals what? Can I reduce that? Divide by 2. 76 divided by 2 is 38. So I'm going to write it as 38 over 1, and I'm going to put it in terms of this graph. The y label on your table represents what? Distance traveled in miles. So I went 38 miles in, and my time driving is in what? Minutes, seconds, in 1 hour. Do you guys feel good about that? Okay, let's do it again. So here, this graph shows the number of distance Javier traveled on his unicycle. It shows the distance that he traveled. So do you see this rise over run? That's what we're going to use there. So we're just going to pick 2 points on the graph. And I'm going to pick this point and this point. I'm not going to pick 2 points that are right next to each other because I want to make it a little bit more challenging. So how are the numbers being counted on the y-axis? Each grid line represents how much?
10 miles.
Does each grid line represent 10 miles? It represents 5. Okay, so we're going to count how much we go up. Because if you think about this in terms of a triangle, I have to go up and then I have to go over, okay? So let's see, I go up 5, 10, 15, 20, 25, 30, 35, 40, 45. So I go up 45. Because I'm going up, it's positive. Now the numbers going across the bottom, the x-axis, each grid line represents what? 1. So I go over 1, 2, 3. That's my run. 45 over 3 reduces to 15 over 1. meaning that he travels 15 miles in 1 hour. So I want to talk to you about, what if I had chosen 2 different points? What if I didn't choose the 1 and the 15? What if I had chosen the 2, the order pair 230 and the order pair 345? How much do I go up here? 5, 10, 15 over 1. So notice that it doesn't matter where I pick the 2 points to count from, I end up with the same rate of change. That's called a constant rate of change. What kind of a graph do you have there? Is your graph curvy? No, it's a straight what? Straight line. So when you have a constant rate of change, that's going to give you a linear equation or a straight line graph. It's called a linear function. So I'm going to maybe make a little note right here that says constant rate of change. I call it CROC. Constant rate of change. Like a crock of crap? No, not like that. Constant rate of change is linear. Okay, so we said the rate of change was 15 over 1. And what do we know about this graph? Holy cow, we notice that it's linear. It makes a straight line. All right. Is graph number 3 linear? No, it's made up of a bunch of line segments. Like there are segments in there that are straight, but it's not a linear function. So we're going to find the rate of change in intervals. We're looking at intervals of time. So my first one, the first time interval that I'm looking at is from 5 minutes to 10 minutes. So I'm looking at it from 5 minutes, which is right here, all the way to 10 minutes. So what is that mark that I just put right here? What's that starting point? 75, yeah. So I'm going to write that ordered pair. That's the ordered pair, 5 minutes, 75 beats. And at 10 minutes, what's that ordered pair? 10 what? 10, 1, 10. Okay. So each graph line, each grid line represents 10 beats per minute when I go up. So if I were to turn this into a counting kind of thing, I go up 1, 2, 3. That's 10. 10, 20, 30 plus 5 is 35. That's my change in my Y. What's my change in my X? How much do I go over? 5 minutes. So what is my rate of change when I reduce that? 7 over 1. Okay. Let's look at our rate of change from 30 minutes to 40 minutes. First of all, is that line going up or is that line going down? It's going down, so it's going to be negative. Let's see, I go down 10, 20, 30, 40. And because it's going down, I'm going to mark it as negative, and I go over 5, 10. So negative 40 over 10 reduces to what? Yeah, negative 4 over 1. So this is a chart representing your heart rate, heartbeats per minute over time. So when you look right here, your heart rate increased. What do you think they're doing? Maybe they just started like a strenuous exercise, right? Are there any runners in this room? Soccer players, anything like that? No? Okay. What happens after you, like if you do a sustained activity for a long period of time, what happens to your heart rate? What were you going to say? When you first start an activity, it does. But if you do that same activity for a long period of time, your heart rate does what? It levels out. It's going to level out. So do you see where it says what is happening during the interval of 10 to 30 minutes? That's this right here. This is from 10 minutes to 30 minutes. My heart rate doesn't change. So it stays the same. Whereas before that, it's increasing, and after that 30-minute time, it's decreasing. Can I go back to example 2 for a second? And Dakota, leave your hands to yourself. You got it? Okay, does everyone have number 3? Okay. All right. So when a function, we already said this, God bless you. When a function has a constant rate of change, it is called what? I just wrote that note. It's called a linear function. I really want to change the color. It's called a linear function. So when a function has a constant rate of change, it's called a linear function. And why do we call it linear? Because the graph is what? Is a straight line. Good job. So we're going to determine if the function is linear or not. And we're not looking at a graph, we're just looking at a table. We know that it's going to be linear if it has a constant rate of change, meaning that the change in y over the change in x is the same all the way through. So let's look at this first example. What's the change in y? The next one. And again. What's the change in x? And again. And again. Oh my gosh, is that from? You are so awesome. Thank you so much, sweetheart. So when I look at that, I'm going to write these as fractions. I'm going to compare each set. So this is my first fraction, 6 over 1. And it has to be equal to the next fraction, 6 over 1 and 6 over 1. And this is true, correct? These are equal to each other. God bless you. So is this function linear? Yes. It's linear because it has a constant rate of change. Croc. Okay, let's look at this next one. To go from 5 to 1, what did I do? Minus 4. To go from 1 to negative 4, what did I do? Minus 5. And to go from negative 4 to negative 10, okay. What am I doing on my y-axis? Plus 8. Next one. Plus 8. So you can tell negative 4 over 8 does not equal negative 5 over 8, right? So is this one linear? No. Not linear because no croc. Okay, so that's just using that whole, so the only thing that we've done in those first 5 examples is we've used the change in y over the change in x, or we've counted the rise over run, okay? These next 4 or 5 examples are going to be using that equation m equals, do you remember what we wrote up there? M equals y sub 2 minus y sub 1 over minus x1. So I want to talk to you about where those little sub 2s come from and those sub 1s. This is just a way to identify ordered pairs. So if you have a 1 next to it, that means it's the first ordered pair. And if you have a 2 next to it, that means it's the second ordered pair. So when I first start doing this, I probably tend to label my ordered pairs just to make sure I don't mess them up. So I'm going to label these X1 and Y1, and this is X2 and Y2. That just helps me kind of like process what's going on when I first start this. So we're trying to find the slope, and then we're going to graph this line. So let's see. My slope is y2. What value is y2? What? 5 minus y1 over x2 minus x1. So look how I write the minus a negative. What do you guys know happens when you have minus a negative? Yeah, it turns into a great big plus sign. And remember, I want you to just turn that minus a negative into a great big plus sign. So I'm going to get rid of that minus negative and that parenthesis and just turn that into a great big plus just by scribbling over it. All right, so let's simplify. What is 5 take away 2? 3, and 5 plus 3? Can I reduce that? No, I cannot. Okay, I'm going to jump down to this graph really fast. So I want to plot the point -3, 2. -1, 2, 3, +1, 2. And then I want to plot the point 5, 5 over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. It didn't show off on your copy? Okay. Just do your best to plot them on there. So once I plot those points and connect the lines, here's what I want to show you. That we calculated the slope using y2 minus y1, but I could have counted it. I go up 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7, 8. Okay. Does that make sense? Harper, I'm losing you. You're falling asleep on me. Okay, let's try the next one. I'm going to label my points again. X1, Y1, X2, Y2. So my slope is Y2. What number is that? -8. Minus Y1. What number is that? -4. Over X2. What number is that? Minus X1. What number is that? So I have some negatives right in a row, right? Minus a negative turns into a great big plus. This minus a negative turns into a great big plus. So what is -8 plus 4? -4. And what is -2 plus 3? It's 1. So my slope is -4 over 1. Are you guys doing okay with that? Okay, we're going to skip the graphing since you don't have little grids on your... Let's do this one. So X1 and Y1, X2 and Y2. Y2, what number is that? 4. Minus Y1, what number is that? Over X2, what number is that? Minus X1, what number is that? Okay, let's see. 4 minus 4 is, and minus a negative turns into a great big plus. 4 plus 3 is, what is 0 divided by 7? It's 0. I want to graph these points and show you what that looks like. So -3, 4, -1, 2, 3, 1, 2, 3, 4. and 4, 4. When I connect the points, what kind of a line is that? It's horizontal. Why would a horizontal line have a slope of 0?
Because it doesn't go up or down.
Because it doesn't go up or down. Slope is rise over run. There is no rise. There's no up or down. It runs a whole bunch. Like if I count from this point to this point, that's my run along the x-axis, but I don't go up at all. That's why my rise is a 0. Okay? So when you have a slope of 0, I want you to know that that is a horizontal line. Okay, let's do the next one. So I'm going to label my points again, x1 and y1, x2 and y2. All right, Gavin Kane, what's y2?
Y1 or Y2 minus Y1.
No, right, I know that. What is y2?
3.
Thank you. Minus Naya, what is y1? Yes, ma'am. Over Danae, what is x2? Awesome. Aiden, what is x1? Awesome. So I have a couple minus and negatives. I'm going to turn those into a great big plus sign. Great big plus sign. So let's see. 3 plus 4 is, but negative 2 plus 2 is, So what's that going to reduce to? 7 divided by 0 is not 0. Who's got a calculator? Anyone? Someone take 7 divided by 0 on your calculator and tell me what you get. It says error. Yeah, you can't divide by 0. That violates the law. Look at what kind of a line we get. What kind of a line is that? It's a vertical line. So you're not allowed to divide by 0. That is called undefined. And if your slope is undefined, it means you have a vertical line. Because you rise, but you never run. There's no slant on that line. It just goes straight up and down. You can rise a whole bunch, but you never run. Okay? Questions about that? Okay, I have 4 more examples. How are you guys doing? Barely hanging on? Yes? Do we need some Smarties? Okay. Those had little, I hate that. So we're going to do some repairing on our notes. We're going to repair. Those are supposed to have ordered pairs on there. So we're going to do some repairing. Yeah. They're all right over there. I printed everything for today. You can. The big ones I would keep in here, the smaller ones. I think I've got 12 to 15 small ones. So take a look up there. You're welcome. Thank you for saying thank You're welcome. Thank you for saying thank you. I'm going to be a shredder. Hurry up. Those scripts are going to be turned out. I'm losing you. We're almost done. You're welcome. Thank you for saying thank you. All right, we have 4 more examples. 4 more examples. Okay? So here's what I want you to do first. Are you ready to listen? The first thing that we need to do is we need to turn those 2 sets of numbers into ordered pairs. What are they missing? They are missing the parentheses. Good job. So I want to put parentheses around those. So I have 6, 3, and R2. And I'm going to do that for all of them. Okay. So all of those should be numbers in parentheses. So we're going to find the value of R or P. It says find the value of the variable. So it looks like I used R and P in these. And I want to tell you how we're going to do that. We're still going to use that same concept of X1, Y1, X2, Y2. And we're going to set up our formula. So we said that M equals Y2 minus Y1 over X2 minus X1. Okay? But I know what M is supposed to be. What is M? 12. And I'm going to write it as a fraction. So 12 over 1 equals, what is Y2?
2.
Minus, what is Y1?
3.
Over, what is X2? Minus, what is X1? Okay. So I know that that looks hideous, but it looks like a proportion. One fraction equals another fraction. Do you guys remember that? So I think that I can simplify the 2 minus 3. How can I rewrite that? 2 minus 3. What is 2 minus 3? So I'm going to rewrite that as negative 1 over R minus 6. So 12 over 1 equals negative 1 over R minus 6. All I did was simplified that, okay? How do I solve a proportion? I forgot. Don't everybody shout it out at once. I'm smiling underneath my mask. You can't see it. What do you think? What if I do this? If I do this, it's going to give it away. Oh, cross multiply. What is negative 1 times positive 1? What? If I add them, it's 0. I said if I multiply them, negative 1 times 1 is negative 1. How do I do this? How do I do 12 times R minus 6? No. The R minus 6, yeah, that R minus 6 is in a parenthesis. 12 times R minus 6. Gavin says you got to distribute that. Okay. So I have to take 12 times R and 12 times negative 6. Listen up. So I have negative 1 equals 12R minus 72. Okay. Please and thank you. So now what am I going to do? I'm solving for R. So I'm going to add 72 to both sides. And I get that 71 equals 12R. Divide both sides by 12. And I find out that R equals 71 over 12. Is that a nice number? No, it's not. It's a horrible number. Are you digging to China over there in your backpack, bud? You're trying to what? All right, we're going to do it again. We have 4 more examples. Hopefully one of them turns out nice. All right, so let's label them X1, Y1, X2, Y2. Remember the equation, M equals Y2 minus Y1 over X2 minus X1. My slope is what? Negative 58. I'm going to write it over 1. Negative 58 over 1 equals, what is Y2? Negative 1. What is minus, what's Y1? 4 over, what is X2? 3 minus P, thank you. So let's simplify this really fast. What is negative 1 minus 4? It is. So I have 58 over 1 equals negative 5 over the quantity 3 minus p. Cross multiply. Negative 5 times 1 is negative 5. Negative 58 times the quantity 3 minus p. So someone has to figure out what negative 58 times 3 is. So negative 5 equals negative 174 plus 58p. What do I do next? Add 174 to both sides. So 169 equals 58p. Divide both sides by 58. It's not going to be a nice number, is it? Nope. 169 over 58 equals p. There's no way that we could have solved these by looking at them, right? We could have never guessed what that number would be. This is the only way to do that. Do you guys want to try C? Someone want to try it? Someone want to tell me what to do step by step? My throat is so sore. Someone take the reins. What do you want to do? I'll go ahead and label them. X1, Y1, X2, Y2. Someone tell me what to do.
I can try, but I'm a little confused myself.
Okay, try it, Kate.
Okay. So I haven't solved it on
So what are we going to do? Y2.
Yeah,
What is that?
negative 3 and then plus 1
Minus
minus
Y1 over
R minus 8.
minus a negative 8, right?
Yeah, that would make that possible.
Turn that into a great big plus. I agree.
And then negative 3 minus 1 equals, that would be negative 4, right?
It would be. So I really have 12 over 1 equals negative 4 over R plus 8. This one's going to come out nice. Okay, keep going.
You did a distribute. Oh, okay.
So cross product, negative 4 times 1 is negative 4 equals 12 times the quantity, R plus 8. Now we're going to distribute.
And then that'll be 12R. Wait,
You're right. I think that's 96.
yeah.
Okay. Keep going.
This is right.
I'm just solving a two-step equation.
Okay. Minus 96 by both sides.
Good job.
And then that's a negative over 3. And then it's a decimal.
But we can reduce it, right?
Yeah.
What can we divide by? They're both even. We could divide by 2. Could we also divide by 4? Yeah. What's 100 divided by 4? So negative 25. And what's 12 divided by 4?
3.
So you probably got 8.3 repeating, right? Negative 8.3 repeating?
Yeah.
Okay. Do we solve for repeating decimals ever?
No.
No. We have to leave it as a fraction, right? Okay, someone different. Good job, Kate. That was awesome.
Yeah. Not really.
Abigail, did I see your hand up for a second? Abigail, did I see your hand up for a second? Amira, did you have your hand up?
No, but I can try to do it.
Oh, awesome. I'll label them for you. X1, Y1, X2, Y2. So our slope is 3/4. 3/4 equals, go. Negative 9 minus
Yeah, minus,
negative 3. Cool.
and then you do R
Yep.
minus 1
Minus 1/2.
and half.
Ooh, that's yucky. Okay, that's right. We can do this. I have minus a negative. I'm going to turn that into a great big plus. Can I simplify this? Yeah. What is negative 9 plus 3? Negative 6. So I have 3/4 equals negative 6 over r minus 1/2. So let's do the cross product. 4 times negative 6 is negative 24. And then I have 3 times the quantity r minus 1/2. So I have to distribute that 3. And when I do that, 3 times r becomes 3r. And 3 times negative 1/2 becomes negative 3 over 2. Is there another way to write negative 3 over 2? I didn't hear that. What'd you say? Yeah, we could call it negative 1.5. Yep. All right. How do I move this? What do I do? Add what? Add 3/2 to both sides. So I'm going to leave it as a fraction. So let me think. Negative 24 is the same thing as negative 48 over 2. Is that true or false? How did I determine that?
Inverse operation.
Well, negative 24 is the whole number, negative 24 as a fraction, negative 24 over 1. I just multiplied it by 2, right? Top and bottom to get a common denominator. So I have negative 48 over 2 plus 3 over 2. So fraction rule says that you keep the denominator, you add the numerators. That becomes negative 45. So negative 45 over 2 equals 3r. So the rule is to divide by 3, but what if I do the reciprocal? What's the reciprocal of 3 if I multiply? So dividing by 3 is the same thing as multiplying by what? 1/3. Multiply both sides by 1/3. So I get negative 45 over 6 equals r. Can I reduce that?
Negative 7.5.
No, it's not. Dividing by 6 is not going to make that a 0.5.
Negative 75 divided by 6.
It's negative 45 divided by 6. Can I reduce that? Aren't they both divisible by 3? Divide by 3, negative 15 over 2, which is what Gavin said, negative 7.5. I just wanted him to think it out. Okay. All right, so your homework, Mr. Kane, make sure you circle these pages, okay? So you have 3 pages. Question 1, 2, 3, 4, 5, 6. You're going all the way till it says more slope practice. You're stopping at more slope practice. So isn't that 3 pages of homework? Okay. Yes, you may. So 3 pages of homework. Now I numbered my note packet and I did not number your guys' note packet. That's really not true. I numbered it using headers and footers, but they didn't work. So I wrote on here that you are completing pages 10, 11, 12. If you numbered your packet, it would be pages 10, 11, and 12. Okay? You also have this Delta Math slope review. You have 2 things. Okay? Got it?